Hello and welcome to my Pre-Algebra review series. This video covers Chapter 7, Section 4, entitled Write an Equation. By the end of this video, you should have a better understanding of the process required to write an equation. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It'll more than likely help them, and it certainly will help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to notify every time I release a new video. Thank you. Objective 1. Write an equation. Scientists write and use equations and formulas every day. Banks use equations to calculate interest and loan information. Statisticians use equations to find sports and population statistics. Doctors use equations to calculate the correct doses for medications. Engineers create and use equations and formulas every day to solve problems related to real-world events. Thus far, you have written one-step equations for word problems. Now you'll extend your skills to more complex situations. Our first example here is a real-world problem. It's a problem with moving van bills, I guess, and the cost of a moving van. So it says, the problem states here, a moving van rents for $29.95 per day plus 12 cents per mile. Ms. Smith's bill for a 2-day rental was $70.46. How many miles did she drive? Okay, so let's look at the pieces of this question and see if we can put some order to it. So we're going to read and try to understand the problem. Starting off, step 1, what is the goal of the problem? And as we look through it, we can see that the goal is to find out how many miles Mrs. Smith or Ms. Smith drove. So it says right here, how many miles did she drive? Okay, so that's the first question. The second question is, how long did she have the van to rent? Well, we know here that it was a bill was for a 2-day rental. So now we know we're looking for how many miles. We know that she had it for 2 days. And it says, what does the van cost without mileage? So without mileage, it says that it's $29.95 per day minus the mileage. And then plus the mileage, we're going to find out the mileage charge is 12 cents per mile. So we're adding two things together. We got the $29.95 per day plus miles. So we're going to have two different things we're adding and to come up with one answer. Okay, so this is what we know about the problem. So let's plan on how we're going to solve this. What are we going to do? Well, in words, it says 2 days times $29.95 a day. So Ms. Smith had the van for 2 days at $29.95 per day. That's the first part. Plus she had 12 cents per mile times the number of miles. We don't know how many miles. That's the question. How many miles did she drive? We know the total cost was $70.46. We know that. Okay, so if we piece this all together, we can say, let's let M equal the number of miles driven. Some variable, might as well call it M because it kind of matches miles, M for miles. And then well, what do we have to do to write the equation? So writing the equation, we're going to take 2 days times $29.95 times $29.95 a day plus 12 cents times the number of miles. And that's all going to equal $70.46. Okay, we have that. We see it. 2 days at $29.95 a day plus 12 cents per mile equals, her bill equaled $70.46. So we're going to solve it on the next slide. So here's the equation from the previous slide. We don't have to go over it too much. 2 days, $29.95 a day, 12 cents a mile, M miles, $70.46 total cost. So now we're going to rewrite this like an equation instead of spread out. So 2 times $29.95. That's one price. That's one piece of the price. 2 times $29.95. The second piece is 12 cents times the number of miles. And then that equals the price. That equals the price for the 2-day rental. And also note here that I added these parentheses, this one, this one, this one, and this one, for clarity. It's not needed because of PEMDAS, which PEMDAS says you have to do everything with inside parentheses, and then you have to do exponentiation, and then you have to do multiplication and division before addition. So you have to do this multiplying and this multiplying right here, and this multiplying right here before you can do the addition. Okay, so we're going to take and calculate this. 2 times $29.95 is $59.90 plus 12 cents per mile times m miles. So that's 0.12 m is equal to 70.46. Next step is to undo the arithmetic. So to undo the arithmetic, we're going to take $59.90 and we're going to subtract it from both sides. Because it's plus $59.90, so you have to subtract $59.90 or add the negative inverse, the additive inverse. Okay, so now the $59.95s cancel over here, and we're left with 0.12 m, and the $59.95 calculated against the 70.46 gives us $10.56 for mileage. All that's left now is to find out how many miles. And to do that, we're going to clear the variable's coefficient so we get the m variable all by itself. So then we'll know what 1 mile is equal to. So we're going to multiply by the multiplicative inverse of 0.12, or I guess we can say the reciprocal. And the reciprocal of 0.12 is 1 over 1.12. Same over here. We're going to multiply this side times it and this side times 1 over 0.12. When we do that, these cancel, and this gets divided into 1056, and you'll find out that m equals 88. Ms. Smith drove 88 miles. Okay, so under check our understanding for example 1, it's the same problem that Mrs. Smith had, except Mr. Jones is going to rent the same van now for 3 days. So as we look at it, it's going to be a 3-day rental, and his bill was $104.49, and we know that from the above problem that it was 0.12 cents per mile. So we're going to figure that out. We're going to plug in the information. So this time we have 3 times $29.95, and we get $89.85. Okay, and these numbers are staying the same, 0.12 m, and except this is $104.49. So then we're going to take and clear the addition and subtraction. We're going to undo it. So this time we're going to subtract $89.85 from both sides, minus $89.85, and we'll end up with 0.12 m, 0.12 cents per mile, times the number of miles. And we're going to subtract $89.85 from $104.49, and we're going to get $14.64 under our simplification step. Then once we've simplified it, we're going to say, well, we need to get rid of the coefficient of the variable. And the coefficient of the variable is the same as it was before. It's right here, 1 over 0.12. We're going to divide by that, or multiply by this inverse here, the reciprocal. We got it on both sides. So this is going to cancel out here, and it's going to cancel out the 1, 2. On this side, this is going to divide into the 0.12 is going to divide into 14.64. And when you do that, you're going to get m equals to 122 miles. So Mr. Jones drove the van 122 miles. He had it longer, so I guess he gets to drive more miles. Okay, so now we're going to start some exercises. There happen to be, I think, 11. And they're all story problems like this, and we're going to go through each one of them one at a time. So the first one here says solve by writing equations for all of these. We're going to do it. So in number 1, the sale price of a sweater is $48. $48. And the price is 20% less than the original price. What was the original price? So the first thing we're looking for is, what's the question? It says, what is, I'll call it P, the price. What is P? Okay. We know that what the sweater sells for, the final cost is $48. Okay, $48. And how did we get to that $48? Well, we started with the original price, the O price, and we multiplied it by something. And we're going to figure out what that is in just a second here, to get the price for $48. And well, what did we multiply the original price by? Did we multiply the original price by 20%? Or some number other than 20%? Well, think about it. If I said that I have something I'm going to sell that costs $10 and I'm going to give you a 10% discount, am I going to sell it to you for $9? Or it's going to go for $9. Yes. So what that really means is 20% in this equation. The trick here is that you have to take 20% from 100%. So you start with 100% and you subtract 20% from it, equals 80%. So that's what you're going to be multiplying the original price by. Okay? So given that information, you're going to say that the original price, and we're going to call it P times 0.8. Not 80%, we have to convert it into a decimal. So we're going to say 0.8 times P is equal to the final price, 48, is equal to 48. Okay? So now we're going to solve a simple equation. What does P equal? P equals, we're going to have to get rid of the coefficient of P to find out what P equals. What did it start with? So we're going to do what? We're going to multiply each side by the reciprocal of the coefficient. That times 0.8 times P is equal to 48 times 1 over 0.8. So to do this, this is going to cancel this, and we're going to have P is equal to 48 divided by 0.8, and that comes out to what? Do we know? 48 into there. I think it's 64, I think is what the number ends up being. Let's find out here. I think it's 64. No, it's 60. It's 60. Okay? Is equal to $60. And now it makes sense, because if you take 10% of 60 is 6, and we're taking 20%, so it's 12. So 60 minus 12 is 48. Yep, got the answer. There's the solution to this first one. The second problem, Elena has $240 in the bank. She withdraws $15 each week to pay for piano lessons. How many lessons can she afford with her savings? So she has $240, so that's understood. And what does she want to know? How many lessons? And we're going to say L as for, or let's do N for number of lessons. So we're going to say that the N is equal to the number of lessons. She has $240 as her savings, $240. Okay, and she wants to take lessons for $15 per lesson. And that's basically all we need to know. We need to come up with an equation that says this is where she's subtracting the money from. Okay, and we want to find out the number of lessons, so we're going to say that $240 is going to be equal to something. And what's it going to be equal to? It's going to be equal to $15 times the number of lessons. So $15 times, if it was 10, it would be 150. Well, that's less than 240. So where this number is going to be somewhere higher than $10 or whatever, or 10 lessons. So let's figure it out. In order to do it, we have to clear the coefficient of the n variable here of the number, which is 15. So that means we're going to say divide both sides by 15. The reciprocal of 15 is 1 over 15. So we're going to multiply this side by 1 over 15 times 240. And that's going to be equal to 15n times 1 over 15. So these 15s cancel. And 215 goes into 240 how many times? Let's see, I'll calculate this. 240. Okay, doing the math seems to be 16 lessons, I think it is. So we're going to say it's 16 lessons. So n, or 16, equals to n. Okay. Okay, continuing on, we have problem 3. Problem 3 says the perimeter of a rectangle is 64 centimeters. There's 64 centimeters. And the length is 4 centimeters less than twice the width. So what is that telling us? The length is equal to twice the width minus 4. That's what the length is. So the W is what it is. The length is 2 times the width minus 4. And that's all equal to, when we're done here, 64 centimeters. So writing the equation is, oh, and by the way, if you have a rectangle, there's 2 lengths and 2 widths. You have the opposite each other. You have the lengths opposite each other and the widths opposite each other. So it's 2 times the addition of the length and the width. So let's go ahead and do that. Let's write the equation for this problem that way. 2 times the width plus the length. And the length we said is 2w minus 4. So 2w minus 4. Put a parenthesis here. When you put the length in, you could have had parentheses on this, so that you could see it would be w plus the value of 2w minus 4 to keep it clear. Not necessarily necessary, though. And that all equals 64. And it is centimeters. So we have to take care of everything inside the parentheses first, because of PEMDAS. And this is all addition and subtraction. So we have 1w plus 2 w's minus 4. And it's all times 2. So we're going to say 2 times 3w, 2w plus 1, minus 4 equals 64 centimeters. So now we know this is as minimum as you can't simplify this any further. You can't add 4 to w's or subtract them. So we're going to multiply this out using the distributive property. So it's going to be 6w, which is 2 times 3w, 6w, minus, ends up being minus 2 times 4, which is 8. And that equals 64 cm. Okay, now we have to get rid of the addition and subtraction. We have to undo that. So to undo it, we're going to have 6w minus 8 plus 8 equals 64 plus 8. So the 8's take care of themselves. We have 6w is equal to 64 and 8 is 72. And now we have to undo the division and multiplication. So in order to do that, we're going to multiply by the reciprocal of the 6, which is 1 over 6. W is equal to 72 divided by 6. Okay, so W is equal to 12. Next problem. Wendy bought a drill at a 10% off sale. So everything at this sale was 10% less than the original price. The sale price was $75.60. They want to know what P is. What is the price? Well, first of all, we know they're looking for P, so that's the question. The question here is, what is P? P equals what? Okay. We know the final price is $75.60. What we don't know is the P they're asking for. We do know that it's 10% off. $75.60 is 10% off of the P price. Well, can we just do anything with the 10% directly? No, because 10% off implies what? 10% implies 100% minus 10% equals 90%, because that's 10% less than 100. 10% less than 100 is 90. So given that, we're going to take 0.9, the decimal version of 90%, and we're going to say that P, 0.9 times P is what the final price is. The final price was $75.60 in dollars here. So now we got to look for what is P? What's the original price? Well, in order to do that, we have to undo the multiplication here on this side. And you do that by multiplying by the reciprocal or the multiplicative inverse. So 1 over 0.9 times 0.9 P is equal to 75.60 times 1 over 0.9. Well, these cancel, the 0.9s cancel, and you're left with P equals 75.60 divided by 0.9, and that comes out to 80. Okay, P equals $84. That was the original price. Okay, continuing on with problem 5. It says here that Lamar's summer job is mowing lawn for a landscaper. His pay is $7.50 per hour. Lamar also makes $11.25 per hour for any time over 40 hours that he works in 1 week. So in our problem here, he worked 40 hours last week, plus an additional N, right here, N overtime hours, and made $339.38. The question is, how many overtime hours did Lamar work? Well, so we know he's getting $7.50 per hour for every hour that's 40 and less. And they're told here that he worked 40 hours last week plus. So in this equation, we know that we're going to be taking $7.50 and we're going to be multiplying by what? It's going to be multiplied by the full week, because it's $7.50 per hour for anything 40 hours and less. And we know he worked at least 40 hours last week because he worked 40 hours plus some overtime hours. So that is times 40 plus his overtime. So this is his regular pay, and now he's going to do his overtime pay. And his overtime pay is how many N hours at $11.25 an hour. So now we have $11.25 times N, the number of hours that he's going to work. We had to come up with some hours, N hours. So $7.50 times 40 plus $11.25 times the number of overtime hours should equal out to be $339.38. That's what they're saying. Find the number of hours he worked in overtime. How many overtime hours did he work? Well, $7.50, we have to multiply this. We have to do this addition here, this multiplication here. We have $7.50 times 40 is 300 plus $11.25 times N is just that, 11.25 N. And that all equals 339.38. Okay, so now we're going to clear out the addition and subtraction. We're going to undo it. So I have to subtract 300. 300 minus 300 plus $11.25 times n hours equals 339 minus 38 minus 300. And that these 300s cancel, so we're going to get $11.25 times n overtime hours is equal to 339 minus 300 is equal to 39.38. Next step is to clear out the coefficient of the variable by multiplying by its reciprocal, and therefore we have 1 over 11.25 times 11.25 n, the coefficient here, equals 39.38 times 1 over 11.25. Okay, and if we do this math, it's going to come out to be, this is going to cancel, and we're going to get n is equal to 39.38 divided by 11.25, and n will be equal to 3.5 hours if you round it. If you go out here way far, it isn't a perfect integer or half integer. So anyways, 3.5 hours is what this ends up being. 39.38 divided by 11.25 is 3.5. 3.5 overtime. He worked 43.5 hours last week. Okay, number 6 here. This is going to be an interesting problem. You're not going to solve it with an equation, but we're going to just do some thinking, which, when you think about it, it's going to help us in the future, because what we're going to be doing here is a lot like factoring some equations in the future. So it says find two whole numbers. These are all whole numbers only. So like factors kind of a thing. Find two whole numbers with the sum of 15 and a product of 54. Oh, well, what could those be? Well, we can use a table to solve this. We can put in some samples and figure it out. It says use the table and trial and error method. So list out, it says what are the whole number factors of 54? And then list them and the sums. So what are the whole number factors of 54? So we have 54 times what? Times 1. And then we have, what is there, 27 times 2, 54. The next one is 9 times 6 is 54. And any lower than that, we're going to get a 6 and go up, so they're all going to be reversing. So now what are the sums? 54 plus 1 is 55. That's maybe, I don't know, we'll find out. Is that high or low? Does that match? Is that 54, I guess? Yeah, 27 plus 2, that equals what? 29? The next one, 6 plus times 6 is 54, and 9 plus 6 is, well, I'm not going to do that, is 15. So this is even, and this is high and high. So the answer is 9 times 6 and 15, or 9 times 6 is 54, and 9 plus 6 is 15. That's the answer to our problem here. Okay, looking at our next problem, problem number 7. A farmer is building a square pen 21 feet on each side. He puts one post at each corner and one post every 3 feet around the perimeter of this pen. How many posts will he use? Well, we know that he has 21 feet on one side. It's a square pen. And he wants to know every 3 feet how many posts it's going to take. Well, we know what is the length of the perimeter. Might help to know that eventually, but what we're going to end up doing is 21 times 4 is equal to 84. Okay, so that might be helpful when we get done writing this out. And he wants a post every 3 feet. So if you start at the corner and you go 3 feet, you got one post, keep going. And at the end of 21 feet, you're going to have a post. So there's going to be so many posts. Then you're going to turn the corner and do posts again, another corner, post again, another corner, post again. That's the picture. If I drew it, it would look something like this, right? You got a little pen with posts in the corners. And he's got 1, 2, 3, 4, 5, 6, 7 posts or whatever. He's got these posts all the way around. So how many posts will he need to buy? So we know that he has, it's 21 feet times 4 is 84 feet total around this pen. And given that, we're going to know that it's every 3 feet is a post. So the number of posts, n, is equal to 84 feet divided by 3. That's what he has to do. He has to, right? Okay. So what is that solution? So there's nothing to be done here. It's an interesting little problem. I'm not sure if they thought it was tougher than this, but we just set the problem up. And if we take n, the number of posts is equal to 84 divided by 3, that ends up being, what does that end up being? 84 divided by 3 is, I don't have to look at this. Okay, it looks like it's going to be 28 posts. There it is, 28. Sorry for taking time to figure that out. 28 posts. So we do that. We got, starting right here at the corner right there, we got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 on that corner. 1, 2, 3, 4, 5, 6, 7 at that corner, and 1, 2, 3, 4, 5, 6, 7 to that corner. So there you have it, 28 posts. Okay, the next problem, it says it takes 8 painters 6 hours to paint a wall of a gymnasium. A, how many person hours does the job require? So the person hours is how many hours times the number of people. So it takes 6 hours to do a job and 8 people did the job. So it took 8 times 6 person hours. So to solve A in this problem, A says 6 times 8, right? So it's 8 painters, 6 hours, 8 painters times 6 hours is equal to 48 person hours, okay? 48 person hours. So he says, the next question, how many hours will 12 painters take to paint the same wall? Well, we're going to assume that all these painters are the same efficiency, that not one painter is faster or slower. They all have the same efficiency. So if 8 painters take 6 hours total, which is 48 person hours, then if you have 12 painters, you're going to say what? You're going to say 12 painters times H for the number of hours, and 4 is equal to 48, because it's the same efficiency. That's the key. It's the same efficiency. So it's still going to take, efficiency-wise, the same amount of painting is going to be done, but it's going to take less hours to do that. So I think what we're going to do here then is we're going to say for B, we're going to say that it says 12 painters times n hours is equal to 48 people hours. Okay, so to solve this, n is equal to 48 divided by 12, right? I'm going to do that. So here we took and multiplied, we said 12 divided by 12 times n is equal to 48 divided by 12 is equal to 4. So it took 12 painters 4 hours to a job that 8 painters took to do in 6 hours. So N is equal to 4. Okay? Okay, so moving on with problem number 9. Kathy has a collection of dimes and quarters. The number of dimes equals the number of quarters. She has a total of $2.80. How many of each coin does she have? So they're giving us a little hint. They're saying that let N equal the number of dimes. And since the dimes are 10 cents, it's going to be 0.1 N. It's going to be the worth of the number of dimes she has. And you're going to let N equal the number of quarters. So that's kind of convenient. It's going to be 0.25 or 25 cents times the number of quarters she has. That's going to be the value. And those two added together will give us $2.80. And then they also say at the end here to change everything into cents so we can get rid of the decimal points. So it's going to be 280 and 10N and 25N. And that's pretty much the problem right there. So it's $2.80, which is 280, is equal to the 10N for the dimes plus the 25N for the quarters. So N number of dimes and N number of quarters, because we know they're equal, is equal to 280. So now it's time to combine the like factors. So we're going to have 280 is equal to 10 plus 25 is 35N. Now we have to clear the coefficient of the variable term, the 35. We need the inverse of that. So $280 times the inverse of 35, or the reciprocal, it's going to be 1 over 35, is equal to 35N times 1 over 35. Same on both sides. So this 35 and this 35 cancel. So N equals 280 divided by 35, and that happens to be 8. So there are 8 dimes and 8 quarters. Okay. So now, problem 10. The weight of an object on Venus is about 9/10 the weight of its weight on the Earth. And the weight of an object on Jupiter is 13/5, 13 over 5 times the weight, its weight on the Earth. So if a rock weighs 23 pounds on Venus, how much does it weigh on the Earth? Well, problem A here, they want to know if something weighs, first of all, we'll say that on Venus, it's 9/10 of the Earth. So we can say Venus is equal to 9/10 Earth. Weighs less. And the Venus weight is 23 pounds. 23 pounds is equal to 9/10 of its Earth's weight. So all we have to do now is clear the variable from its coefficient by multiplying by the reciprocal. So 23 times 10/9 is equal to 9/10 times E, the Earth's weight, times 10/9, the reciprocal. So these reciprocals cancel, and we're going to have 230 divided by 9. 230 divided by 9 is equal to the Earth's weight. So if we take it and figure out what that is, and more specifically, instead of this fraction, if we divide 9 into 230, we're going to get 25. And 9 times 5 is 225. And 225 from 230 leaves 5, so the remainder is 5. So it's 25 and 5/9. Okay, so now we're going to do the same thing for Jupiter. So the weight on Jupiter is equal to the Earth's weight times 13/5. Okay, so we know the Earth's weight. So Jupiter is equal to the Earth's weight, which is 25. I'm going to take that back. 200, I'll erase that. Jupiter is equal to 230 divided by 9 times 13/5. So here's the Earth's weight right here of that rock, and here's what it would weigh in Jupiter, and now we just have to carry out the mathematics. So the weight on Jupiter is going to be 230 times 13 is 2990. And the if we take and then that is divided by 9 times 5 is 45. Okay, so if we take 45 into 2990, you're going to have 66 and some value x over 45. Well, 66 times 45, so J, Jupiter's weight, is 2990. 66 times 45 is minus 2970. Okay, so that's going to be equal to 20. Because 2970 is 45 times 66. I subtracted that from 2990, and I have 20. That's the remainder when I divide by 45. So the answer then is 66 and 20/45. And I'm running out of space for it, but 20/45, J's weight, Jupiter's weight, equals 66, and 5 goes into 20, 5 goes into 45, and 4/9. 66 and 4/9. Okay, here we are at our last problem, problem number 11, and it says, Jackson, Petra, and Tyrone went to the beach and collected seashells over the weekend. Jackson collected S seashells. Petra and Tyrone each collected 13 fewer than twice the number of shells Jackson collected. It's kind of like that earlier problem I had. At the end of the weekend, they had collected 94 shells. How many shells did each collect? Well, we have Petra, we have Jackson, Petra, and Tyrone. And from what we can see here is that Petra and Tyrone, the number that they have is based on Jackson's value. So it's going to be Jackson's value, which they say is S seashells. So S is Jackson, plus how many altogether did Tyrone and Petra have? Well, they each had twice S. So we're going to say, and since it's two of them, I could write this twice or I could multiply it out. So I could say, I'll just do it singularly. So it's 2S minus 13 for Petra, because she collected twice Jackson's amount, minus 13, plus Tyrone did the same thing. He had twice Jackson's amount, minus 13. And the alternative is we could have written it S plus 2 times 2S minus 13. We could have done that. It would have been the same thing. And this equals 94 shells, total of 94 shells. Well, this one is all addition up here. There's no multiplication, so we'll do the one with the addition. So it's S plus 2S plus 2 more S's is 5 S's. And then it's minus a 13 and minus another 13. So it's minus 26 is equal to 94. So that's how many shells they totally collected. So now we have to undo the math. The subtraction here. So 5S minus 26 plus 26 is equal to 94 plus 26. Because to undo the subtraction. So now we end up with 5S is equal to, these cancel, is equal to 94 and 26 equals 120. So to find out how many shells Jackson had, S, we have to get rid of the coefficient, which is 5, by multiplying by 1 over 5 times 5. S is equal to 120 times 1 over 5. These cancel, so S is equal to 120 divided by 5, which is how much? So 5 goes into 100 how many times? 20 times. 5 goes into 120 4 times. So it's 24. $24 is what Jackson collected. And so Petra and Tyrone collected, so Jackson had, J had 24. Petra and Tyrone had 2 times 24, right? Minus 13. So 2 times 24 is 48. Minus 13. Oops, that's a 13. 48 minus 13 is 38. Minus 3 is 35. So 35. So Petra and Tyrone each had 35. And if we add them up, we have 24 plus 35 plus 35 is equal to 94. 35 and 35 is 70, and 24 is 94. Okay? Thanks for sticking with it.